In this lecture, we shall be learning about hydrocarbon compounds. Hydrocarbon compounds are organic compounds that contain only carbon and hydrogen atoms linked by single or double or triple bonds. So, hydrocarbons are organic compounds. They contain only carbon and hydrogen atoms. Classification of hydrocarbons. They are classified based on carbon-carbon bonds. Let us see the classification. First one is saturated hydrocarbons. They have only carbon-carbon single bonds. Remember, they are covalent bonds. So these are called saturated hydrocarbons. We'll see why they are called saturated hydrocarbons in a little while. Number 2 is unsaturated hydrocarbon compounds. They have carbon-carbon double bonds or carbon-carbon triple bonds. Next, we have aromatic hydrocarbons. These are special types of hydrocarbons. They are also called arenes. These aromatic compounds are called so because of the smell they have. They have a aroma, so they are called aromatic hydrocarbons. These carbons have alternating single and double bonds between carbon-carbon atoms. So aromatic compounds have alternating single and double bonds between carbon-carbon atoms. So we have seen the classification of hydrocarbons. Based on the nature of carbon-carbon bonds, they are classified into three categories. One is saturated, the other is unsaturated, the third one is aromatic hydrocarbons. Now let us see one by one. First we shall see saturated hydrocarbons. Saturated hydrocarbons. In these, each carbon atom is bonded to maximum number of atoms. The maximum number of atoms each carbon atom can bind is 4. So each carbon in this saturated hydrocarbons will be bonded to 4 other atoms. So no more hydrogen atoms can be added to it. This is important point. In this compound, each carbon atom has 4 bonds and it is combined with 4 other atoms. So no more hydrogen atoms can be added to it. So it is called saturated hydrocarbon. Let us see some examples. Of all the compounds in saturated hydrocarbons, methane is the first number because it contains only one carbon atom. So this carbon atom can have 4 bonds. The 4 bonds are attached to 4 hydrogen atoms. So it is a saturated hydrocarbon. Each carbon atom is bonded to 4 other carbon atoms by single bonds. This is the definition of saturated hydrocarbons. Let's see another example. Ethane. Ethane contains 2 carbon atoms. And each carbon atom is bonded to 4 other atoms. See, the first carbon is attached to another carbon that is one bond, three other hydrogen bonds. So totally four bonds this carbon atom has. Similarly, this carbon atom, second carbon atom, is bonded to first carbon atom and three other carbon atoms. So altogether this also has four single bonds. So this is also saturated hydrocarbon. These saturated hydrocarbons are called alkanes. So remember, saturated hydrocarbons are called alkanes. And these alkanes are of two types. One is open chain alkanes, the other is cyclic alkanes. So first let us see open chain alkanes. Open chain alkanes have a straight chain of carbon atoms or an open chain of carbon atoms. So simplest open chain alkane is nothing but methane, CH4. It is represented as C, that is carbon atom attached to four other carbon atoms by single bonds. So this is an alkane, that is saturated hydrocarbon. Simplest saturated hydrocarbon is methane. The second member is ethane. Now let us see the naming of alkanes. If there is one carbon atom, it is called meth. If there are two carbon atoms, it is called eth. And if there are three carbon atoms, it is called prop. And if there are four carbon atoms, it is called but. If there are five carbon atoms, it is called pent. If there are six carbon atoms, it is called hex. Seven carbon atoms, it is called hept. Since they are alkanes, the suffix is "ane" added to methane. So it becomes methane. Two carbon atoms, prefix is "eth" and suffix is "ane." So it becomes ethane. Three carbon atoms, the prefix is "prop" and suffix is "ane" because it is an alkane. It is called propane. Four carbon atoms, the root word is but and suffix is "ane." So it is called butane. Five carbon atoms, the main word or root word is pent because it has five carbon atoms. Suffix is "ane" because it is an alkane. So it is pentane. Six carbon atoms, the root word or the main word is hex and suffix is "ane." So it is hexane. Seven carbon atoms, the root word or main word is hept and suffix is "ane." When these two are added together, it becomes heptane. Let us see eight carbon atoms. Eight carbon atoms, the root word is oct. Oct means eight. Suffix is "ane." So it is octane. Nine carbon atoms is called none. The root word is known and this is suffix is "ane." So it is called nonane. 10 carbon atoms, 10 is called dec, that is the root word, and ane is the suffix. So it is decane. So we have learnt the naming of open chain carbon atoms. Let us see the general formula. The general formula of open chain alkanes is CnH2n plus 2, that is Cn stands for number of carbon atoms present in the alkane. Whereas hydrogen will have double the number of hydrogen atoms plus 2. So let us see one by one. When n is equal to 1, that is carbon is 1, hydrogen will become 2 into 1 plus 2. That is 2 plus 2, 4. So the formula of methane is CH4 because carbon is 1, hydrogens are 4. When n is 2, it is ethane. Okay. So carbon atoms are 2. So hydrogen atoms are 2 into 2, double the number, 4 plus 2, 6. C2H6 is the formula of ethane. When n is equal to 3, carbon is 3, hydrogen is double the number of 3 plus 2, that is 8. C3H8, this is propane. When n is equal to 4, that is carbons are 4, so hydrogens will be double the number plus 2, that is 10. 2 into 4 plus 2 is equal to 10. C4H10 is the formula of butane. When n is equal to 5, that is carbons are 5, hydrogens will be double the 5, that is 10 plus 2. So this compound is C5H12. Its name is pentane because it has 5 carbon atoms. When n is equal to 6, that is carbons are 6, hydrogens will be twice the number of carbon atoms, that is 2 into 6, 12 plus 2, 14. So C6H14 is hexane. Hex because it has 6 carbon atoms. When carbon atoms are, that is n is equal to 7, hydrogen atoms will be 7 into 2, 14 plus 2, 16. So this is C7H16. This is heptane. Hep because it has 7 carbon atoms. When n is equal to 8, that is carbon atoms are 8. So hydrogen atoms will be double the number of 8 plus 2. That is 16 plus 2, 18. So C8H18 is the formula for octane. Oct because it has 8 carbon atoms. When n is equal to 9, that is carbons are 9, hydrogens will become double the number plus 2, that is 18 plus 2, that is 20. C9H20 is nonane, known because it contains 9 carbon atoms. When n is equal to 10, that is carbon atoms are 10, hydrogen atoms will become double the number of 10, that is 20 plus 2. C10H22 is decane. Decane because dec means 10. 10 carbon atoms this compound is having, so it is called decane. These are the open chain saturated alkanes. Now let us draw the structures of open chain alkanes. Starting with the first member, methane. We all know methane has only one carbon atom, C1. It has 4, because it is saturated hydrocarbon, it has 4 single bonds. All the single bonds are attached to one hydrogen atom each. So this is methane. The second member is ethane. It has two carbon atoms, 1 and 2. These two carbon atoms are joined by a single bond. And each carbon atom in turn is joined to 3 hydrogen atoms by single bonds. This carbon atom is joined to 3 hydrogen atoms. This carbon atom also is joined to 3 other hydrogen atoms. Altogether, each carbon has 4 single bonds. So this is a saturated hydrocarbon. Let's see the third member. Third member is propane. Propane means it has 3 carbon atoms. 1, 2, 3. And each carbon atom has 4 bonds. 4 single bonds, that is. First carbon is attached to second carbon by single bond, and it is attached to 3 carbon hydrogen atoms by single bonds. So altogether first carbon has 4 single bonds. Second carbon is attached to first carbon and second carbon by 2 single bonds. It is also attached to 2 hydrogen atoms by single bonds, 2 single bonds. So altogether second carbon atom also has 4 single bonds. Similarly, third carbon atom is attached to second carbon atom by single bond and is attached to 3 hydrogen atoms by single bonds. So it also has 4 single bonds. So propane is a saturated hydrocarbon or alkane. This is open chain hydrocarbons. Now let us see other members of the open chain hydrocarbons. Butane. We all know that but means 4 carbon atoms. 1, 2, 3, 4. So each carbon atom has 4 bonds. So this is the structure of butane. First carbon has 4 single bonds, second carbon has 4 single bonds, third carbon has 4 single bonds, fourth carbon also has 4 single bonds. Next member is pentane. We all know pentane means pent, 5 carbon atoms, 1, 2, 3, 4, 5. Each carbon has 4 single bonds. See, this first carbon has 3 hydrogen bonds, single bonds, carbon single bond, 4 bonds. The second carbon has 2 hydrogen single bonds, 2 carbon single bonds, so 4. Third carbon has carbon single bond between 3 and 2 and 3 and 4 and 2 hydrogens, 4 single bonds. Fourth carbon has a single bond between itself and third carbon and a single bond between itself and fifth carbon and 2 hydrogen single bonds. So it has 4 bonds. Similarly, fifth carbon atom has 3 hydrogen carbon single bonds and 1 carbon bond. So it has 4 single bonds. So pentane is an open hydrocarbon compound, that is alkane. Hexane. Hex means 6. So it has 1, 2, 3, 4, 5, 6. 6 carbon atoms joined together by carbon single bonds and carbon hydrogen single bonds. Each carbon having 4 single bonds. This is hexane. Let's see. Heptane. Hept means 7. So 1, 2, 3, 4, 5, 6, 7. 7 carbon atoms are joined in a open chain and with single bonds between them, and each carbon atom is joined by single bonds to hydrogen atoms. So each carbon atom has 4 single bonds. Let's see the next structure, that is octane. Oct means 8 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8. These 8 carbons are joined together by single bonds between them. They are also joined together by single bonds to hydrogen atoms. So altogether each carbon atom will have 4 single bonds. So this is also saturated alkane. Next member is nonane. Non means 9. So there are 9 carbon atoms connected to each other by single bonds, and each carbon atom is connected to hydrogen atoms by single bonds. So each carbon atom has 4 single bonds altogether. So this is nonane. Nonane is also saturated alkane or open chain alkane. Next member is decane. Deca means 10. Decane means 10 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbon atoms are joined by single bonds between them. And each carbon atom has carbon hydrogen single bonds. So altogether each carbon atom in this 10 membered open chain compound has 4 single bonds. So this is an open chain alkane. Now let us see cyclic alkanes. What are cyclic alkanes? In cyclic alkanes, carbon atoms will form a cycle. So to form a cycle, minimum of 3 carbon atoms are needed. So alkanes means saturated hydrocarbons. Alkanes with 3 or more carbon atoms can only form cyclic alkanes. This is very important. Unless you have 3 or more carbon atoms, you cannot form cyclic alkanes. So the simplest cycloalkane will be a cyclo compound with 3 carbon atoms. We all know the compound with 3 carbon atoms is called propane. So since it is cyclic, we call it cyclic propane. So we have 3 carbon atoms joined together by single bonds. First carbon is joined to second carbon by a single bond. Second carbon is joined to third carbon by a single bond. Third carbon is joined to first carbon by a single bond. And each carbon atom is joined to 2 hydrogen atoms by single bonds. Thereby, each carbon is having 4 single bonds. So, cyclopropane, 3 carbon atoms of cyclopropane are joined by CC single bonds to form a cyclic structure. Since each carbon atom should have 4 bonds, each carbon atom is attached to 2 hydrogen atoms. So cyclopropane can be represented this way: CH2, single bond CH2, single bond CH2, single bond CH2. Or we can represent it as a triangular structure: 1, 2, 3. So this point represents one CH2 group. This second point represents another corner represents another CH2 group. This third corner represents another CH2 group. This is called a skeletal structure. So the triangle has 3 corners. Each corner represents one CH2 group. So it is C3H6. So the formula for cyclopropane is C3H6. We notice that cyclopropane has 2 carbon atoms less than open chain cyclopropane. We have just studied that open chain cyclopropane is C3H8, but cyclopropane is C3H6. So cyclopropane is having 2 hydrogens less. Similarly, cyclobutane means 4 carbon atoms. They are joined by CC single bonds to form a square or a rectangle structure. Each carbon is attached to 2 hydrogen atoms. So let us see this. This is the first carbon atom. This is the second carbon atom. This is the third carbon atom. This is the fourth carbon atom. First carbon atom is attached to 2 hydrogen atoms by single bonds. Second carbon atom is also attached to 2 hydrogen atoms by single bonds. Third carbon atom is also attached to 2 hydrogen atoms by single bonds. Fourth carbon atom is also attached to 2 hydrogen atoms by single bonds. So each carbon atom has 4 single bonds. Or we can write this structure as CH2 single bond, CH2 single bond, CH2 single bond. 1, 2, 3, 4. 4 single bonds plus 2 each for hydrogens. So it becomes C4H8. This can be represented in skeletal form like a square or a rectangle. Okay. This has 4 corners. 1, 2, 3, 4 corners. Each corner represents one CH2 group. So since it has 4 corners, it represents C4 and H8. So each corner represents one CH2 group. So its formula is C4H8. So the formula for cyclobutane is C4H8. Here also we notice cyclobutane has 2 hydrogen atoms less than open chain butane. We know open chain butane has C4H10. But here cyclobutane has C4H8. So it is 2 hydrogen atoms less than open chain butane. So the general formula for cyclobutane is, or cycloalkanes, is CnH2n. That means cycloalkanes will have carbon atoms. If the carbon atoms are 3, hydrogen atoms will be double, 6. If the carbon atoms are 4, hydrogen atoms will be doubled, that is 8. If the carbon atoms are 5, hydrogen atoms will be double of that number, that is 10. So let's see cyclopentane. It contains, since it is called pentane, it has 5 carbon atoms. They are joined together by carbon-carbon single bond to form a pentagon. This is the pentagon. 1, 2, 3, 4, 5. Each carbon atom is attached to two hydrogen atoms. So each corner of the pentagon represents one CH2 group. So we have 5 corners. So it is C5H10. This also can be represented like this. CH2 single bond, CH2 single bond, CH2 single bond, CH2 single bond, CH2 single bond. So totally we have cyclopentane will have C5H10. This also has 2 hydrogen atoms less than open chain pentane. Open chain pentane has C5H12. So this is having open chain pentane is having 12 hydrogen atoms, whereas cyclopentane is having 10 hydrogen atoms, 2 less than open chain pentane. Similarly, if we see cyclohexane, it has formula C6H12 because we have learnt hydrogen atoms will be double the number of carbon atoms in cycloalkanes. So cyclohexane has 6 carbon atoms. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. And each carbon atom is attached to 2 hydrogen atoms by single bonds. These are all single bonds. In skeletal form, we can draw a hexagon. 1, 2, 3, 4, 5, 6. Each corner of the hexagon represents one CH2 group. So we have 6 corners altogether. So it will have 6 CH2 groups, that is 6C, C6 and H12. Now here also we notice this cyclohexane has 2 hydrogen atoms less than open chain hexane. Open chain hexane has C6H14. So these are the alkanes. So we have learnt alkanes are saturated hydrocarbons with single bonds between carbon atoms and hydrogen atoms. They are divided into 2 types. Saturated alkanes are divided into 2 groups. One is open chain cycloatom, open chain alkanes, which have an open chain carbon-carbon bonds, and cycloalkanes, saturated cycloalkanes. They have carbon-carbon single bonds and carbon-hydrogen single bonds. So in order to form cyclic structures, alkanes should have at least 3 or more carbon atoms to form cyclic structures. So they are cycloalkanes. And cycloalkanes will always have 2 hydrogens less than the open chain alkane of that member. For example, propane will have 2 hydrogen atoms more than cyclopropane. Similarly, butane will have 2 hydrogen atoms more than cyclobutane, and so on. That's all for now. In our next lecture, we should learn about unsaturated hydrocarbon and hydrocarbons or hydrocarbon compounds. Thank you for listening. Please subscribe, share and comment. Thank you very much for your valuable time. Thanks.